Hey everyone, Octavian here. This is the first part of the tutorial in which we're going to be working in Unreal Engine. You've been animating for quite a while, and although you did spend one video setting up the project, that wasn't really working on blueprints or anything of that sort. So this is going to be the first video we're actually going to be working in. Now, what we're going to do in this video is we're going to be spawning a character, creating it first, and we're going to add inputs to move it around. Look around and also run. That's what we're going to do in this one. The first thing we're going to need to do for that to happen is go to our FPS tutorial folder. In there, we're going to go to core, and inside of core, we're going to need to do one really interesting thing is we're going to right click, we're going to go to blueprint class, and we're going to create a player controller. We're going to need this later. We're not necessarily going to add any functionality inside of this player controller. As it says here, the player controller is an actor responsible for controlling a pawn used by the player. As I said, we're not going to add any functionality in it, but we do need to have it created in case we do want to add functionality later. So let's just left click here. I'm going to call this BP underscore player controller. I'm using a naming convention from a style guide that you can find online by someone called Michael Aller. I think that's how you pronounce it. I'll leave that in the description. Now that we have that created, the next step we're going to need to do, I'm going to pop up a window here called the world settings. To make that show up, we're going to go to window, and under that, we're going to find world settings. So just click on that. We need this window because the world settings window has the game mode. Now, right now, you can see that the game mode assigned is the third person game mode. Game mode is basically going to tell us what character we're going to be spawning, and also what player controller we're going to be using for that character, and a lot of other data that we're not going to use right now. We're also not going to add any functionality in this one either, but we will need to create our own character that we can spawn, and also we're going to make our own game mode for that. Now, as I mentioned before, this is the third person game mode. If I click play, it's just going to spawn the third person character, which is this little character referenced right here, where it says default pawn class. Let's create our own game mode, as I was saying. To do that, we're just going to click create new blueprint. I'm going to go to the FPS tutorial folder. We're going to do everything inside of this folder. We're going to go to core, which is where we're going to put all of the functionality blueprints, or basically the main blueprints that we're going to use in the project. And inside there, I'm going to name this GM FPS and then save it. That's going to create a new game mode for us. If I go to the content drawer and open GM FPS, you're going to see that really this is just an empty game mode based blueprint. It has exactly the same properties as it does right here. So we can modify it from either here or here. It doesn't really matter. Now that we have it, what we're going to do is we're going to assign our player controller that we created before. You can do that from here. BP player controller. And then we're going to need a pawn class, just like we have the third person character pawn class. And in fact, let me just show you what happens if we play right now before we assign anything. So right now we have the default pawn assigned, so not the third person character anymore. We can click play and we're going to have this floating camera that we can move around. It's basically almost like the editor camera. We don't really want this. You can change this to the third person character and you're going to have the third person character again. We don't want any of these though. So what I'm going to do is I'm going to create a blueprint for this. To do that, I'm going to go to the content drawer. I'm going to make sure to actually save everything that we've been doing up until now, though. I am very obsessive about saving. You do not need to save as often as I do, but it is good practice to do so. Now I'm going to right-click, Blueprint Class. Inside Blueprint Class, what we were asked for inside of the game mode, if you take a look, it's a default pawn class. Now, a pawn, as it says right here in Blueprint Class, is an actor that can be possessed and receive input from a controller. Creating a pawn would be enough for us to create an FPS character. However, it is easier to use a subclass of pawn, which is character, which is just a type of pawn, as it says right here, that already includes the ability to walk around. This is basically perfect for our use case, so we're just going to create a character. By the way, what we saw before, the third person character is a character. So we can just do that. Character. I'm going to call this one BP character. We're just going to keep it very simple. Now, we have our character. I'm going to open it. We don't really need to do anything inside of it right now, but just to take a look at it, you can see we have a capsule. There's an arrow that basically points us in the forward direction of the character. And then there's a mesh. We don't really need to assign anything to the mesh right now. Just so you can see, this is just a place where you can assign a skeletal mesh, basically. I'm going to Control Z that for now, though. Now, let's go back here. Let's go to our game mode. Again, you can just go to the actual file if you want to. Inside of default pawn class, let's assign BP character, which is the character we just created. And let's try playing now. Now, nothing is going to really happen. I can't move around. I can't look around. There's not much I can really do right now. I'm just going to Shift F1 and eject for a moment. You're going to see we don't really have anything in there, unless, or at least visibly. However, if I go here, you can see that we are spawning a BP character. And if I go to its detail panel, you're going to see that its details basically look exactly like what we just looked at. So it's the capsule component, the mesh, and all of that jazz. Just so we can see that we're really spawning the character, let's go to BP character, and under mesh, I'm just going to assign something that we can see. For example, let's put the FP arms in there. I'm going to rotate them a little bit, move them down. We're not really going to see them very well if I just put them like this, so I'm going to do something a little bit weird and just push them forward a lot, and then compile. Make sure you compile though. Let's go back to the level and then play. As you can see, now we have the first person arms right in front of us. We still can't move or look around, obviously. We haven't really changed any of that functionality. However, we can tell, especially if I eject, that this is our character. Great. That's the first step that we really needed to take. Now, I'm going to just place this back, move it down a little bit. Just place it at -90. That usually works pretty well. And then compile. The thing we're going to do now is we're going to set up all the inputs that we need. To set up the inputs, I'm going to go to the content drawer. Now, by the way, the inputs are just going to be kind of a mapping of the keys we want to press to a name that we can then kind of use in the blueprint and know when they're triggered so we can do some sort of functionality. So for instance, we're going to have a jumping input, and that's going to be mapped to a jump key, which is going to be the spacebar, for example. And then inside of the blueprint, we're going to have an event that's called jump, and then we're going to do all of the jumping functionality. Now, that might be a bit confusing, so let's just take it step by step. First thing we're going to do, we're going to go to the content drawer again. Get used to this. We're going to do this a lot. We're going to go to data, and in data, I'm going to right click, find the input category. Inside of input, I'm going to create a input mapping context. As it says right here, a input mapping context is a collection of key to action mappings for a specific input context. That's very confusing. To put it very simply, this is just going to hold all the references to the input actions we create, which, as it says right here, is a logical representation of something the user can do, such as jump or crouch. So this is going to hold all the actions that we can take. So jump, crouch, run, move, look around. And it's going to map them to specific keys. And this is what our player is going to recognize as the keys mapped to the actions. That's it. So let's create one. Now, since this is called the input mapping context, and that's its data type, I'm just going to start with input mapping context, and then I'm going to call this default for now. Inside here, there is a mappings list. I can add a mapping. As you can see, it's going to ask us for some sort of input action, and then a key for that input action. Ooh, don't save, I guess. We got a little bit of an issue because it's empty. I'm not going to do anything else right now here. What I'm going to do is I'm going to make sure that the player or this character is using this input mapping context. To do that, I'm going to go to BP character. I'm going to go to functions. I'm going to override begin play, which gets called whenever the game starts. And I'm going to do the following. I'm going to type, I just press tab, by the way, or right click. And then we're going to type get player controller. This is going to give us a reference to our player controller. Now we're going to drag that reference and we're going to say get enhanced input local player subsystem. And then from here, we're going to type set input, or I think it's mapping context, add mapping context. That's the function we want. This is going to allow us to tell this character's player controller to use, in our case, this mapping context. Now, it seems we already have a mapping context in the project that's called IMC default. So let's just very quickly rename this one to IMC FPS, maybe, so we don't confuse it. And then I'm going to go back here, and in mapping context, I'm going to assign IMC FPS. And then make sure you connect the execution pin to add mapping context. That will make sure whenever the game starts, we add that mapping context to our player controller. So that means whatever actions we add there, our player is going to know the trigger and kind of how they work. And then we can compile and save. Now, let's add a test action so we can see that this is really working. To do that, all we need to do is we're going to go to add action mapping. Inside of here, we're going to click on create input action. And in FPS tutorial data, we're going to add it. I'm going to say input action, so IA, test, and then save it. Now it's going to ask us for some sort of button to trigger IA test with. I'm just going to say T, for example. We don't need to mind any of this or any of these properties right now, so just ignore that for now and save. This in and of itself is not really going to tell us if we trigger T. If I press T right now, nothing's really going to happen. We still need to tell it what to do when we press T. To do that, we're going to go back to our character blueprint, right click, and we're going to search for the same name that we made our action, sort of whatever we called it. In this case, it's IA test. And we're going to add this one with the little arrow. This is going to add an event for this action. And whenever we press T, in this case, whenever it gets triggered, what we're going to do is we're going to print a string to the screen. And we're going to say testing. This will make it so whenever we press T, we're just going to have a little pop-up text that says testing. Let's compile that and save it and go back and try to play it. Now, if I press T, you can see if I hold T, it's going to say testing. Great. That's great. Now that we know that our input mapping context works and we can add actions to it, we're going to create a movement action. How do we do that? Well, it's going to be the same process we did to add the test action. So we're going to go to the IMC FPS, so our input mapping context for the FPS. And we're going to add a new action mapping, create a new input action inside of our data folder. So input action movement, and save it. Now, movement is a little bit more complex than just pressing T. So we're going to have to add a few more mappings here. First of all, we're just going to click here, add control binding, and do that 3 times. So we have 4 mappings. That's going to be our WASD. And then in here, I'm just going to click select the key value and then press W, press A, press S, and press D. That's basically all of our mappings here. Inside of these mappings, we're going to have to do a little bit of work, but for now it is totally okay to just leave them like that. First, we're going to go to the actual IA movement action, open it. I just went to the content drawer here, and then again, we're in content, FPS tutorial, and data. And then inside of this action, we're going to need to change its value type right here, which is the type of, or the type that this action returns, from digital bool, which we don't really need in this case. What we're going to do with this is we're going to make it a vector 2D. Why are we making it a vector 2D? Well, it's because a movement action generally has two axes. So we're going to need two values that go from -1 to 1. We're going to have a horizontal value, which is going to move our character kind of left to right. And then we're going to have a vertical value, which moves it from forward to backward. So that's going to be A and D for the horizontal, and then S and W for vertical. So make it a vector 2D. And save that. Now, let's go back to our mapping context. In here, we need to make sure that these are all mapped properly to the different axes. By default, pressing any of these buttons is going to return 1. And in fact, we can really test that. So for example, if I go to our character, again, add the action event right here. So that's going to be IA movement. Ignore move. That comes from the third person template. So just bring up movement. You're going to see that we get a action value right here, which is a vector 2D. That's the difference with the with IA test, for example, which was a Boolean value. And in triggered, I'm going to copy this print string and just connect it there. And then I'm going to drag the value of action value into the in string. That's going to print whatever value we have right here. And if I compile, save, and then play, if I press W, you'll see we get 1 on the x-axis, which is not exactly what we want. We want W to be on the y-axis, though you could have it on the x-axis. That would be fine. But for this tutorial, we're going to have it on the y. If I press A, you see we also get 1. If I press D, we also get 1. And then if I press S, we also get 1. That is not great. So let's fix that. Let's start with fixing W being on the x-axis. It is positive, which is correct. We should be, if we move forward, we do want that to be positive number. But it is on the x-axis and not the y. To fix that, we need to go to the input mapping context. And then in here, unfold this drop down for the W key under movement. And under modifiers, we're going to add an element. And the element we're going to add is going to be called Swizzle Input Axis Values. You see it says useful to map a 1D input onto the y-axis of a 2D action. So click that, save, and try to play it. If I click W now, you'll see it's on the y-axis. If I click A, it's going to be on the x, D is going to be on the x, and S is still going to be on the x. Next thing we're going to fix is S being on the x. So same thing there. I'm going to go to the S, add a modifier of type Swizzle Input Axis Values. The only difference that we're really going to make here is that S should be negative. To make it negative, all we need to do is go to modifiers and add another modifier, and this modifier is going to be negate. You can see it says inverts input per axis. So just give it that too. Go back here. If I press W, it's going to be positive on the y-axis. S is going to be negative on the y-axis, which is great. And then A is still positive x, and D is still positive x. All we need to fix now is A being positive 1 on the x-axis. To do that, we're going to use our friend the negate modifier. We're going to go to A, modifiers, and then negate that. That's great. Now, if I just click play, we get all the different inputs. Now, we need to actually do something with these inputs. It is very simple to add movement to a character, especially if you're already using the character class. All we need to do is, whenever we trigger the movement, we're going to call the add movement input function. And it's going to ask us for a world direction. Now, if you don't know much about world and local directions, all you really need to know about for now is that a world direction is basically the direction that shows up, that is kind of the forward of the world, the up of the world, and then the right of the world. And then there is a local direction to each actor, which, like right now, you are looking at kind of the X of the world, the Y of the world, and the Z of the world. And then if we look at the local version of that, which we can cycle right here, this is the actors, so the player start in this case, local X, local Y, and local Z. This function asks us for a world direction, so we're going to need to make sure that whatever value we pass it is world. If I just pass this value right here and I just allow it to convert from our local input, it is local because we're not really taking into account the world at all. It's just a -1 left, +1 right, and a 1 forward and a -1 backward. We're not doing anything special. If I just pass it this and then compile, we are going to be able to move. And in fact, if I press forward, we're going to move. This is W. We are not moving forward to the character. We're moving forward in the world's forward direction, as I was mentioning before. And then if I press A, we're going to move in this weird direction too, and then D is going to move us in this direction. So it's all a little bit jumbled up. We need to convert the local values that we have to a world value. How do we do that? Well, we're going to separate things a little bit. To start with, I'm going to take this action value, which is, again, our input. I'm going to break it. So I just called this, I dragged, and then I called this break vector 2D. This is just going to give us the two values separated, basically. I'm going to take our forward, which in this case is the Y. That's going to contain 1 if we press W and -1 if we press S. We want this to be, or we want this to move us forward wherever the character is facing, always. The way to do that is we're going to multiply this by the character's forward direction. That will make sure that we're always applying this value in the character's world forward direction. To do that, all we need to do is get actor forward vector. This returns the actor's forward vector in world space, as it says right there. And we're going to multiply. All I'm going to do is just find the multiply action. And we're going to multiply that by the Y. And then plug this into the world direction. Do keep in mind that we're not applying the left and right movement at all right now. So it's just going to be forward and backward. Compile and play. Now if I press W, you see that we're moving actually forward. If I press S, we move backward, so that's correct. If I press A, though, we're not even moving, and then D, we're not moving at all. So let's fix that. To fix that, we're going to do exactly the same thing. In fact, I'm going to just copy and paste this and connect it next in line. And then we're going to do the same setup, but instead of forward, we're going to make sure that we move along the actor's right vector, which in our case is basically going to be the horizontal line. To do that, we go get actor right vector. And then we're going to multiply by the X. And then apply that into this movement input. Compile, save, go back, play, and now if I press A, D, we can move forward, we can move all around, everything seems to be correct right now. Great. That is basically our entire movement setup. Now we're going to need to move into the camera. To do the camera setup, we're going to start by adding a mapping context, just like we did with the movement. I'm just going to fold that for a moment. And it's going to unfold by itself, of course. And create a new input action. We're going to call this one look or camera. Save it. Fold that again. Now here, I'm not going to actually select any key value because it's not really a key that we want. We want the mouse's up and down and left and right axis. So all we really need to do, there is a thing called here, if we search for mouse, it's going to give us mouse XY 2D axis. This is exactly what we need. We don't need to set up anything else. That's all we really need. So we're going to save. Let's make sure that our IA camera action is also a 2D axis instead of a Boolean. Otherwise, we're going to have issues later because we're not going to be able to get the value or the correct value. So let's go to the action. Inside value type, change this to axis 2D, vector 2D, just like we did with the movement action, and save. And now we can go to our character and add this action. So IA camera. This is going to give us an action value. To make our camera rotate, just like we had add movement input, there is also a function for this, which character provides us. In this case, if I right click, it is called add controller, or yeah, add controller input. There is multiple ones. We have add controller pitch input, add controller roll input, and add controller yaw input. Now, let's just add a few of these. So add controller. I'm going to add to our graph pitch and yaw input. Now, pitch is basically the up and down rotation, you could consider it. So the pitch is going to be, if I go to a random object and I press E to go into rotation mode, pitch is going to be this axis right here, in the case of the character at least. And then our yaw is going to be this axis right here. So that's going to be exactly where we want to rotate. We're going to want to rotate around the character when we look left and right, and then up and down the character whenever we look up and down. We're not really going to be rotating the entire character with this. This would be a little bit weird. We want our collision to stay exactly the same. We're going to rotate the camera instead. That's all going to be done by default though. So let's just go here. We have add controller pitch input and add controller yaw input. As I mentioned, pitch is going to be up and down and yaw is going to be left and right. So all we need to do is we're going to connect these, bring our action value to a break vector 2D node, and then X is going to be left and right. So we're going to put that into yaw, and then Y is going to be pitch. So up and down, and then compile, play. If I look left and right, it's all working perfect. If I look up, I'm actually looking down. And then if I look down, I'm actually looking up. That is a bit of an issue. But other than that, we are looking in the correct direction. We can move forward in that direction. So everything seems to be working correctly. Now let's press escape. Let's go to our character. To fix the up and down being inverted, that being our pitch, all we're going to need to do is take this Y value and multiply it by -1. That will completely invert the value. And thus, whenever we move up, it's going to move up. And then whenever we move down, it's going to move down. So compile, play. So if I look down, if I look up, now everything seems to be correct. I can look and move around, and we're all set with the movement and the looking. I said I would do one more thing in this tutorial, and that is adding running. So let's do that. That's also going to be really pretty simple in this case. We're going to take exactly the same steps that we did for pretty much everything else. We're going to go to our data folder. In this case, I'm going to right click and create an input action from here. It is the exact same thing. So IA, in this case, I'm going to call it run. We don't need to make this a vector 2D. We don't need two values for running. We just need to know whether we are running or not. So a Boolean is going to be perfect. If you don't know what a Boolean is or a vector, you might want to look into a few tutorials in terms of that. This might be a bit too advanced for you. But in any case, let's save that. Go to our mapping context. In the mapping context, I'm going to add an action mapping and again fold all of these. I don't know why Unreal does that. It's very annoying. And then in here, just assign the run mapping or the run action. And under the run action, I'm going to click on the key value and just press left shift. Same process as every other time before. I'm going to go to the character, type IA run, and that will give us a event that calls its triggered pin whenever the running starts. Now, how do we make a character run? Well, turns out, again, with the character blueprint, this is also very simple. If we go to the character movement component, which as it says right here, it is the component that handles movement logic for the character, and click on it, we'll see its details panel. And inside of its details panel, there's a lot of stuff. We can ignore most of it for now. The only thing that I'm going to focus on right now is this max walk speed value. This says the maximum ground speed when walking. This is the speed at which our character is moving right now. And you'll see if I set this to 2000, for example, and then I click compile and go to the level and I move, you're going to see that we move a lot faster than before. This is what we need to change to simulate our character running. That's pretty much the only value we need to change. So let's do that. I'm going to reset that. By default, it's 600, so reset that. So how do we change that? Well, we drag this component into our blueprint. That's going to give us a reference to it. And then from it, it's very simple. We're just going to drag a pin, and then we're going to type set, and then the variable's name, so max walk speed. And that is going to give us this function that sets the value of max walk speed. So all we really need to do is whenever we trigger the run, we are going to connect this. Right now it's going to set it to 0. We don't really want that. So we're going to set it to 2000, just like I was doing before, and then compile. If we play now, I can walk around. I'm pretty slow. And then if I press the left shift key, I'm suddenly very fast. Now, this doesn't stop ever. I am just very fast by default now, forever. Even if I stop and start doing or start walking again, it's just going to sprint all the way. To stop this, we're going to need, in this event, we're going to need to expand it. There is a completed in, which, as it says right here, it basically says triggering has finished. In our case, this is what we're going to use to reset the speed back to 600, which is the default. So we're going to copy this, paste it, which I just did Control-C, Control-V, by the way. And then in completed, we're going to connect this one and change the 2000 for a 600. And then compile. Play again. I can walk around, I can sprint, and then if I stop sprinting, I am walking again. And then sprint again, stop sprinting, I am walking again, sprint. You get the point. And that's basically sprinting. I'm just going to do one more little thing, and this is just the nice touch. You don't need to stick around for this one. We are already done. We can move around, we can look around, we can run. None of the stuff that I'm going to do now is necessary, really. What I'm going to do is I'm going to make the camera change its FOV whenever we sprint. Right now, you can't tell as much except for the speed that we're sprinting. So one thing that a lot of games do is they change the camera's field of view a little bit. They expand it a little bit whenever you sprint. So we're going to do that. How do we do that? Well, first thing we're going to need to do is we're going to need to add a camera here. Well, actually, we don't need to add a camera here. Okay, this is a good way to kind of demonstrate my thinking process. So instead of that, we are going to press tab and then search for get camera. We're going to find this get player camera manager. Now, this function returns the player's camera manager. This is basically a blueprint that takes care of, well, as it says, managing the player's camera. From here, I don't believe we have a set field of view, so we need to get camera. Okay, so instead of get camera, what we're really gonna do is we're gonna kind of set default FOV. This is gonna be what we're gonna do. This is gonna change the camera's field of view. So at a very basic level, all we need to do is connect this after we start running. So whenever we set the max walk speed to 2000, and I'm just going to clean this up a little bit. Sorry, this is a bit of a OCD habit of mine. And I'm going to change the camera's FOV. I think the default might be 90, so let's just change it to something like 100. And then when we stop running, I'm going to change it back to 90. Now, if it is 90 by default, we're going to notice, but I think that's going to be okay. Now compile, save. This is what it looks like right now, the entire graph. I'm, again, just going to clean that up. Let's try it. So if I start running, the FOV is going to change very suddenly, and I'm going to feel very fast. And then if I stop, it's going to kind of pop back in. That is very sudden, though, so we might want to smooth that. To smooth it, we have a bit of a black magic trickery thing in Blueprints. There is a component called the timeline. So if I type add timeline and I hover over it, it's going to tell us that a timeline node allows values to be keyframed over time. So that's basically what we want. We want to smoothly, or kind of over time, make or change the field of view. So I'm going to add a timeline. I'm not going to call it anything for now. And if I double click on this, you're going to see that there's a very complicated graph. It seems, at least. It's really not that complicated. The only thing we need to do here is we're going to click on track, add a flow track, and this is going to add a curve that we can animate and ask us for a name. I'm going to call it field of view. And inside field of view, you can right click to move around this graph, and also right click and then add key to add a point to it. I'm going to add a point to time 0. We're going to give it value 90, and then I'm going to right click and add another key at time, let's say it's going to take 0.3 seconds for us to run, and we're going to give it value 100. So this is going to be our FOV from when it starts to when it finishes, kind of ramping up. If I press F now, we're going to see the keys perfectly. Let's also change the timeline's length to 0.3, which is our last keyframe, so that whenever we start playing, it finishes at the last keyframe. And then select both keys and press 3, which will just make them a little bit smoother. We can get out of this timeline now by just going back to the event graph. You're going to see that in the timeline, we have a FOV pin now, and we can use it now. How do we use it? Well, all we need to do to use it is, instead of plugging our kind of calling the set default FOV value, I'm going to take that out, and we're going to, right after setting the max walk speed to 2000 when we're running, I'm going to call play from start in the timeline. That will start this timeline and change this FOV value as it says right here. So it's going to go from 90, as it says right there, to 100 over 0.3 seconds of time, and then it's going to finish because that's our maximum length. And then we still need to assign this FOV value, so let's assign that right here. Instead of setting 100, we're going to set it to whatever the timeline gives us whenever it updates, which is going to be pretty much every frame, I think. And that will scale our FOV up. So if I compile and then run, you're going to see that it very smoothly changes the FOV, and then if I stop, it suddenly kind of pops back. Now, instead of play from start, actually, because this might be causing some issues, just click on play, because this gets called every frame, so if we type play from start, we might have issues. So just press play, and then, yep, you can see that it kind of smoothly scales now. What we still need to do is we need to restart that, or kind of play it from the back. So whenever we stop, we're going to reverse that and then compile. Play again, and if I run, it smoothly goes back in, sort of smooths out, smooths in, smooths out, smooths in. And yeah, that's it. We have the running, we have the movement, we have the looking around, we have everything. That's basically it for this tutorial. I hope that was helpful. I will see you in the next one, where we will be adding jumping, which is going to be very simple and very short as compared to this one. So yeah, I'll see you in the next one.